Training and Learning Academy's 1-week faculty development program on smart cities organized by Government Engineering College Bilaspur. And I am overjoyed to take this opportunity to introduce our resource person of this session, Professor Niranjan Manohar Deshakar. He has graduated in electrical engineering in 1984 from VNIT and post-graduated in power systems in 1986 from VNIT. And he has worked as lecturer and assistant professor in various colleges. He has worked on different academic committees in Nagpur University, also worked in Senate and Management Council as a member in Nagpur University. He has 35 years of experience in the field of electrical power systems and automation. He is first generation entrepreneur working in core electrical engineering. He works as a chief technical advisor for Technodeal and HVLV group of companies. He has worked as electrical consultant for Smart City at Nagpur. He will be discussing on topic electrical energy considerations in smart cities. So I invite Professor Niranjan Manohar Deshakar for his address. Please, sir.
Okay. Thank you, madam, for glorifying introduction about me. I welcome all the participants in this faculty development program that the Government Engineering College Bilaspur has organized. I'm very happy that the topic that you have decided for the faculty development program is a upcoming and emerging topic. And it includes the all engineering branches also. It is interdisciplinary, or rather I will say it is a cross-disciplinary topic. It's a very vast topic. It is very difficult for me to compact my presentation. The electrical energy considerations in the smart city. So one by one we will discuss now. This is just the introduction. Madam just has given it to you. I am joining here with you with my younger generation entrepreneur, second generation entrepreneur, Chinmay Harkare. He is an alumnus of my own institute, Ramdeo College of Engineering and Management. He is B in Electrical Engineering and MTech in Power Electronics and Power Systems. And presently he is a director technical of the Technodeal Enerpower Private Limited and a managing partner of the HVLV Consultants. This is just the introduction of our work since last 35 years. As the technology is growing and technology changing day by day, we are entering into the new sectors and the baskets of the technology. This is just our introduction. Now, let us start our discussion. A few slides I will be covering regarding the outline. I have gone through the complete program of faculty development program since 6th of September. It may be a little bit repetition for you people, but it is customary for me to focus on the outline of the smart city concept. See, the smart city concept, actually, we have to ask some questions. What is a smart city? Why do we need smart cities? How do we implement the smart cities? And the smart city focus areas that to identify first, and the electrical supply in the smart city generation, problem of carbon emission, what should be the power quality in the smart city in general, and in particular also what is the Indian energy scenario, the smart grid, the microgrid, and how to manage the demand curve management. I suppose that the participants, they are all from all the branches, electrical, electronics, mechanical, civil, maybe some architects will be there. It's basically demand curve management will be understood mainly, but I have made it very interactive and a layman can understand that, and how it is beneficial to the smart city, that also I will explain. The another outline is electric vehicles in the smart city, the vehicle based carbon emission. I have focused some points on that. Then electric vehicles, the solar PV, and which is a lucky combination. How it is lucky combination, that also I will just throw some light on that. The smart city EV charging system, which is the buzzword nowadays. Electric vehicle is a buzzword nowadays because the government has decided that by 2030 almost 80% of the vehicles on the road will be running on electric energy to reduce the carbon emission and to become India self-sufficient as far as the fossil fuels are concerned and the oil is concerned. The smart EV charging, see, it is a new phenomenon basically, and it is normally said that the necessity is the mother of invention. As the necessity increases or changes, the inventions are also taking place. It is a very important concept as far as the smart cities and the sustainable smart cities are concerned. Green buildings and the smart cities, that combination is also very, very important. It is important from the point of view of civil engineering and architects about the uh, green building accreditation for the new buildings, the existing building. I will also share some slides, one or two slides on the green building. What is the green building features that make building green, the buildings green uses, the energy efficient buildings, and ECBC. ECBC is basically civil engineering people, they must be knowing this particular norm, that this is the code. Okay, and according to the code, the buildings should be designed and so on and so forth. ECBC categories that we will also discuss. The lighting power density is a very niche area as far as the energy consideration in smart city is concerned. The building envelope, what type of building should be there so that the building should be green, the sustainable, energy efficient, and so on and so forth. The passive design strategies and the sample cases also I will discuss in this particular presentation. Now let us start. The smart city uses modern techniques too to improve the operational efficiency, share the information with the public, provide a better quality of the government service and the citizen welfare, and enhance the city's livability. These are the concept and the salient features of the smart city we are talking about nowadays. The metrics to evaluate smart city are the efficiency and the sustainability. These are the only two pillars on the basis of which the smart city is working complete throughout India. The concept has been conceived by Honorable Prime Minister of the country, the Modi ji, and you will be surprised to know that there are many smart cities has come up in India. So, what are the metrics? I mean, what are the points that will successfully transform a particular city into smart city? Is its electrical grid, the gas distribution system, the water distribution system, the public and private transportation system, and commercial buildings and hospitals and homes. When we talk about the sustainability, it is very important. Basically, when we talk about sustainability, we talk about three types of sustainabilities. Number one is the environment sustainability. Number two is the social sustainability. And the third one is the financial sustainability. Now, what is a sustainability? Sustainability, I can define sustainability as development that meets the needs of the present people or present community without compromising the ability of the future generations to meet their needs. Okay. And I continuously go on telling this because you have to assume that the natural resources like water, the green teas and whatever it is. See, you have to consider yourself that you have borrowed this particular natural resources from your future generation and you have to give it back. That is the essence of the sustainability. Okay, so you have to keep the things reserved to be used by your future generation. So environmental sustainability, the social sustainability, and the financial sustainability are the major aspects to be considered. As far as energy considerations are concerned, Energy considerations for smart city will be covered in the environmental sustainability. It has nothing to do with the social sustainability and financial sustainability, but some threads are there connected between all these three, amongst all these three part of it. Next. Why we need the smart cities? Let us ask some question for that. Let us go back and some on the basis of the data which is there. It is said that the 9 billion people will be there in the urban area by 2050. Okay, so it's very difficult. It's very difficult for to accommodate these people in the urban areas. They are pushing and pulling to the urban areas. The cities already face an overpopulation crisis and are environmentally unsustainable. I move around India for my consultancy work, and I have seen the people, they are deprived of the basic necessities like electricity, water, and transport. Push and pull concept, I will just let you know in the next slide. The cities already face this overpopulation. You also must be facing this particular problem where you are staying actually. The scarcity of the resources, the social and economic imbalance, and the poor quality of life. That is the another part that is responsible for giving out these smart cities. A city must work for the support of its people, the people attracted to the cities due to push and pull factors. Now, what are these push and pull factors? Basically, you try to understand when you go into the villages, okay, the people there, they are deprived of the livelihood. Basically, they are distressed, the scarcity in their place of origin, the drought, the violence, the social rifts, and because of that, these people, they are pushed towards the urbanization area or urban areas. The another 180 degrees opposite is the pull factors. It is like better opportunities, the education, the business, the industry, good livelihood, leisure, the cultural aspects. So basically, these particular factors, they are very, very important, and they are responsible for the smart cities basically to enhance the livelihood and sustainability today as well as in future. So this is all about why we need the smart cities. How do we implement the smart cities? As you know that the technology and the ICT, information and communication technology, enabled the smart solutions and the system to improve. Today, I'll give just you the example. I'm working in Telangana, and my person who is doing my job, he is hardly 10th passed. Okay. Now he can show me here that what he is doing there by using the ICT, the smart solutions. Daily he is giving me the pictures there. He is talking with me in the video conferencing mode. Isn't it? It's really amazing. The technology is being used for the useful purpose. I need not go every time to Telangana and just monitor the work. So this is how the things are. This is called as unified communication. The unified communication is the sustainability as far as the environment and social aspect is concerned. Okay. So unified communication has, I mean, the technology has made it very, very simple. You can see the faces, you can see the people, what they are doing in US, and you can see the people, how they are doing in offices and so on and so forth, logging in, and the pandemic has already taught us so many things. Okay. So the operational efficiency and sustainability of the city infrastructure vis-a-vis its transportation and mobility, water, energy utilities, and urban planning and development. So this is all possible because of the ICT enabled technology. Governance and administration, day by day, the governance of the government is increasing. I mean, it is going towards good part of it. It is a good governance and administration, public safety and ease of living. As far as governance is concerned, I have been working in this particular field since last 35 years. I am observing the change. I am not supposed to go into the office of the distribution company to submit my application. Sitting at a home, I can submit the application, and I can just track my application that where it is getting blocked. isn't it? One fine morning, I get a message, I get a mail that your application is approved and pay online this much amount, and within 5 days, the energy meter will be coming to your house. That is really amazing. See, the governance, the administration, public safety is something different. It is regarding the security and surveillance. Also, I will touch that particular point. Ease of living, the social services, education, culture, and healthcare. Now, a major often overlooked component of the smart and sustainable cities are the smart and sustainable buildings. We'll discuss that because ultimately that decides the energy consideration, how much energy you are going to use optimally. This is very important. The optimum use of the energy has to be there. So one by one we will discuss. This is just the flow chart and this is the diagram where you can just see the interlinking. A smart city, a smart citizen, a citizen has to be smart. My father is 92-year-old and he can use the smart home. Can you imagine? Okay, so citizen has to be smart. He can communicate with his doctor with a video conferencing. Isn't it an achievement? Though it is not in the smart city, but smart citizens. The smarts in industry, smart transportation, smart health, smart energy, smart governance, smart lighting, smart buildings. These are the building blocks. Then in the smart citizen, the training and awareness, I have just quoted the example. In the smart industry, the increased productivity through M2M combination. That is smart transport. It is the intelligent road, railway, airport, traffic management. Everybody is experiencing this particular smart transport system also. The smart health, the healthcare during corona and pandemic, every doctor utilized this ICT for the betterment of the society. It is the social sustainability, you can call it as. Smart energy will be focusing more on the smart energy, the smart grids, the microgrids for smart generation, distribution, transmission, and utilization and consumption of the energy. The governance is you have to frame the policies for that because unless you frame the policy, it would be a chaos as far as all these systems are concerned. The efficient policies and the planning with the citizen involvement. So it should be inclusive policies. Basically, every cross section of the society should be taken into consideration while forming the policies also, because everything depends upon the government policies. Smart lighting, the intelligent lighting system. Uh, this is a very common thing nowadays since last 5 years down the line. I have experienced it that every person or every owner is to go for the smart lighting or automation, home automation and the lighting part of it. Energy efficiency and the security solutions. So all parts are covered here and the same infrastructure and integration. Okay, so all blocks, they are communicating with each other. That is the beauty of this particular interconnection and integration. Smart city command center. This is also very important. The smart water network, smart energy grid, which we are going to talk about it. Intelligent traffic and transport management, solid waste management, data center, safety and security, early warning system, and smart mosquito density system. Dengue is spreading like anything. So you have a solution for everything. If you have the efficient solid waste management, then I think the question of mosquito doesn't arise. Even liquid waste management also is there. Okay, so basically everything is interrelated. This is the I visited Kochi. So it is the smart city command center. It's amazing. Basically, you can monitor each and everything, be it a water consumption, be it a electrical consumption, be it transportation, which roads are blocked roads, which roads are very free, whether the street lights are working or not. Everything is monitored here, which is called as the human machine interface. So it is the command center is very important and it is needed in the smart city. the smart city near Nagpur, with which I am concerned about, the command center was not proposed. I persuaded this matter with the local administration that you must know or you must have the command center. Now the proposal has already been framed for that. Because see, you can monitor that how many people are there, how many dwellings are there, which are the commercial spaces, which are the residential spaces, which are the hospitals. So every consumer, every client is using energy, is using water. Okay, so the data of each and every person is must be available in the command center itself. It is the control. It is not basically the control, but it is the monitoring. So once you monitor the thing and you set your benchmarks, and those who are crossing the benchmarks, you can have the penalties in the policy which the administration will frame days together. Smart city focus areas, the adequate clean water supply, reliable, sustainable, quality electrical supply, the sanitation, efficient urban mobility and public transport, affordable housing, this is very important. Then robust IT connectivity and digitization, good governance, environmental sustainability, I already told you, energy efficient and green buildings, safety and security of the citizens and healthcare. Out of all these things, we'll be focusing ourselves on the reliable, sustainable and quality electrical supply, energy efficient and green buildings, that also we will focus in details. Electrical supply in the smart cities, electricity generation. Everybody is aware now that the main generating source in India has been and is with the help of the fossil fuel, thermal power plants. Can you imagine that the thermal power plant is burning the coal, and so it is causing the carbon emission account for around 50% of the energy related carbon emissions. This is really alarming issue for the carbon emission. Okay. Another source is the water, that is hydro, but that is not being used day-to-day life. So thermal and hydro, these are the conventional sources. Now we have to complement these sources with the renewable one. This number also has the highest year-on-year rate of increase. The smart cities, to be sustainable, must minimize the use of the fossil fuel based electricity. Ample cost-effective renewable solutions are now available, and smart cities must generate their own electricity by using either the smart grids or the microgrids. For your information, France is the company, or France is the country uh, who is asking and requesting the people in the France to use the nuclear power generated electrical power. Nobody is using there. Every power that is being utilized by the citizens of France is either the tidal power or the solar power or the wind power or the renewable power. It is very simple to say all these things within a statement of say 1 second or so, but it is not that easy. Integration is very important for that. So electrical supply and power quality. We talk about the power quality, a steady state voltage regulation. The voltage sags and voltage swells. The transient voltage stability, the surges in the supply that may affect the ICT tools that are to be restricted. These are the considerations. Then the surges and dips, the frequency stability in India, the frequency is 50 hertz, 50 cycles per second. And if the frequency is not stable, the all electronic gadgets and the ICT tools, they may maloperate. We do not want that. The smoothness of the voltage curve waveforms, that is the harmonics. Harmonics are generated because of the nonlinear loads. And the nonlinear loads are nothing but again electric vehicle charging stations and so forth, and that will pollute the power system as a whole. Then the continuity and reliability of the power supply. That is very, very important. The above metrics can be kept within permissible limit through modern power system design and control methods and flexible AC transmission system devices. That is called as FACTS. Let us come to the Indian energy scenario. India is the third largest producer of electricity in the world. We are generating 373 gigawatts. Okay, out of which I am happy to share with you that 38% of the generation is going by renewable sources. About 5 years back, it was hardly 10 to 15%. It is because of the governance. The policies are made in such a way that every person who is staying in India is free to generate the power, and if that power is not required by him, he should be in a position to export it into the grid and he will earn money out of it. This is really amazing. When we graduated, we never thought about this particular concept. But now, rooftop solar. You just install rooftop solar, you can sell that particular part, you can utilize that particular part. It is a two-way process. It is a net connected one. Okay. 240 million Indians live without access to the electricity. This is another darker side of the India. Many people, many villages, they are not still electrified in spite of the policies which are framed, but that will improve this year by year. That is improving. Losses. It's absolutely India and Africa. These are the two countries where the losses are very high. 23 to 25% of the transmission or the power goes into the losses. And these losses, they can be bifurcated in two parts. It is the system loss and another is the theft. So in smart city, we have taken into consideration how to restrict the energy theft or the power theft rather. Okay. So for generation, availability of fuel and renewable energy infusion has been addressed. Additional transmission capacity and inter-regional capacity is being addressed. Smart and micro grids. The smart grid use IT and communication technologies, the consumer information, data locked continuously to improve the operational efficiency, smart meters, the smart substations, smart distribution and smart generation. As far as the smart meters are concerned, we are having this particular part for you. A smart meter is a meter. It is an electronic device that records the consumption of electrical energy and communicates the information to the electricity supplier for monitoring and billing. A smart meter is an electrical meter that records the consumption of electrical energy in intervals of an hour or less. Why I'm focusing my attention on this? It is because the energy considerations we are discussing about. Every day you must have the data that today how much units of electricity has been consumed. This data will help you to strengthen the complete system as a whole, so that all of a sudden it should not happen that the shutdown or the breakdown or load shedding should be experienced by the citizens of the smart city. So this data will get compiled and it will give you the alarm that average consumption of the electricity in a particular day has gone up and we don't have the generation for that. So this matching of the demand and supply is very important as far as the energy and power is concerned in the smart cities. The smart meter is the electrical meter that records it communicates that information at least daily back to the utility for monitoring and billing purpose. The smart meter enable two-way communication between the meter and the central system. So it is AMI, that is advanced metering infrastructure, and automatic meter reading system. The communication from meter to the network may be wireless or via fixed wire connections such as PLC, power line carrier communication. This is a very old technology. We studied about it, but it is being practiced now. On the same power line, you can have the communication also override with that having some carrier frequency, and the communication can be done by the load dispatch center with the generating station regarding the demand and supply information. The wireless communication option in common wireless ad hoc networks over the Wi-Fi, wireless mesh networking, low power, long range wireless, Zigbee. These are the different platforms. Wi-Sun, the smart utility networks. So basically, it is all integration of all the utilities. So the smart metering is very, very essential from the point of view of energy consideration. Ultimately, because of the smart metering, actual billing is done and the monitoring is there. At the end, I will tell you the real scenario of the smart city, the smart metering. This is the single line diagram or the block schematic of the power provider and the user. So the power provider is providing the power by way of the cables or the overhead lines. I mean, in the smart city, we cannot expect the overhead lines. Everything is underground. It's a great challenge for the urban development ministry. It is a great challenge for the architects to plan the roads, the stormwater drainages, the electrical corridor, the non-electrical corridor, everything. So the smart meter user one, he is using air conditioners, refrigerators, washers, and so on and so forth. So you have the users along the this particular line, the power provider line, and the same both the provider and the user, they are interconnected by using the either the local area network or the power lines communication and so on and so forth. Means you cannot hide your consumption. That is the main aspect. If you are using an air conditioner, it will be monitored. It will be known to the control room that you are using a air conditioner today. Which span of the day, between which particular span of a day in a 24-hour you are using air conditioners. That I mean, everything is clear. You can retrieve the data also. So this is another thing. Smart transmission and distribution. As I told you, presently the thermal, hydro and nuclear power, these are the conventional power systems or power generators. Smart grid technology gives an opportunity to use both renewable and non-renewable sources as well as uses of the stored energy. I will be focusing this particular point on the stored energy. Okay. Transmission. Electric transmission system carry large amount of power at high voltages from generations to substations, and the transmission system must be kept highly reliable to prevent the blackouts, ensure robust energy markets. Then synchrophasor technology has emerged as a key enabler for improving the transmission reliability and operation. And other things are also there, the phasor data concentrators and so on and so forth. Fiber optic technology has come into picture. The distribution technology has changed now. In place of the three-phase transformer, now in smart cities we are proposing high voltage distribution type of the concept. Every transformer who is stepping down the voltage, because the utility voltage for normal application is either 230 volt for a single phase system and 400 volt for the three phase system. Every transformer is a smart transformer. We are working on it. It is not yet implemented in the system, but this work is being carried out at our Technodil group basically. I want to make every part of the power system as a smart power system. I must get the information from the transformer which is remotely placed. Every transformer will have an IP address, and according to that IP address, I should be in a position to assess whether the transformer is lightly loaded or highly loaded. If it is lightly loaded, can we add some load on that? Can we shift the load from one transformer to the another transformer so that the possibility of the blackout or possibility of the fault can be reduced? So HVDC has already told you. So the electrical losses, that is the another part which we have to minimize, because the cross section through which we are transmitting and distributing the electrical power. Ideally speaking, the complete active power should be transferred to the conductors, and the reactive power which is required for the magnetic flux and magnetic field to be produced in the machine, that can be supported locally also. So it is the optimum utilization of that particular conductor. So this is another part in the smart transmission and distribution. The substations in smart city, the conventional substations are not to be used, because when the smart city is being planned or has been planned, it's a combined effort of every technocrat. The major role is played by an architect who is planning this particular city. So ultimately, the architect asks the every consultant to come out with the space requirement. And in the space requirement, if you go by conventional substations, it requires a huge amount of space. So the same thing I experienced in the smart city at Nagpur. So if the conventional substations are there, then the architect will put down his thumb and he will say that no, I cannot provide you this much space. Then the another type of substation, gas insulated substation, which we call it as a GIS. With gas insulated substation, the size is reduced to a large extent. It is approximately 25% of the space that is required as compared to the conventional substation. The cost is more, no doubt about it, but it is very good. The reliability is good. Operation is, it is a gas insulated, so no question of oil. And again, we are taking care of the environment also. So the space assessment is the first job. Then another assessment is the assessment of the power to be required for the complete smart city as a whole. And that assessment is on the basis of the thumb rule, isn't it? So the thumb rule goes like this, that how much is the total built up area in the smart city? And let us divide and classify this total built up area into three different categories. Number one is the residential area, number two is the commercial area, and number three is the public service. On the basis of this, we prepare one chart that what will be the prospective power that will be required for the complete smart city as a whole. There are some thumb rules, there are some proven techniques, okay, and there are some techniques, the simulation techniques, on the basis of which ultimately when it is everything is in place and when we compare our design process, we come to know that approximately 5 to 7% deviation is there, but while designing you have to assume something with the diversity part of it. So superconducting cable, they are coming into picture. They are used to provide the long distance power transmission. Nobody is using the superconducting cables. The superconductors are very costly nowadays, because superconductor means the diameter of the cable will reduce like anything. Superconducting material is the material, ideally speaking, having the zero resistance. So through the small cross section, you can pump more amount of current. That is the concept. And if the diameter of the cable and the cable bunches go down, then you require a small corridor to carry that cable. Okay. So the cross section of every road in the smart city, either the road width may be 5 meter, 6 meter, 7.5 meter, 9 meter and 12 meter. These are the different sizes of the roads which are normally proposed in a smart city. So the cross section of every road is different. For 12-meter road, absolutely no problem. On both sides, we get a sufficient corridor to carry our cables, the data cables the the power cables also. The data cables normally proposed are fiber optic cables, and the advantage of the fiber optic cable is it can be laid um, with high voltage cables also. So the electromagnetic interference that we talk about in electrical engineering and electronics engineering, that doesn't come into picture. Otherwise, if the data cables are the wired one, copper cables, then you have to take a lot of pains and precautions to keep the safe distance between two cables, and unnecessarily in the cross section, the duct size increases. So everywhere we have proposed that the fiber optic cable is to be laid, so that for the audio, video and the metering purpose, smart metering purpose, complete data can be transmitted through the optical fiber cable, isn't it? Distribution system routes the power from the utility to the residence through the power lines. The switches, the transformers, and the utility typically rely on the complex power distribution schemes. The manual switching to keep power flowing to the consumers. The manual switching is ruled out nowadays, that everything is available on your phone tab, isn't it? A smart building, what we call it as, you need not go to the switchboard to switch on the light. You need not go to the switchboard. See, you can program the things. You can program the things. Mood lighting is also there. Everything is possible. The technology is with you. Everything is possible. So improve the comfort level of the human being day by day. The key component of the distribution intelligence is the outage detection and response. Very frequently, I am using this particular word, that breakdown. This is the worst one. Electricity Act 2003 says that if the breakdown in the system is there, then the consumer can go in the court of law and ask for the compensation. It is not possible in India because the law and order is not in the place as it should be. But see, if it is an outage, I can understand. But if it is a breakdown, means working in a proactive environment is a need of time. It should not be a reactive decision. It has to be a proactive decision. And that is why in the command center discussion, I told you that a complete data of a day about water, about carbon emission, about traffic, about energy consumption should be available in the command center, so that you come to know that what is happening. Why the consumption of the water or why the consumption of the power is increasing day by day. That assessment has to be done proactively, and if it is absolutely for the real purpose, then we should think upon generating the more power. So this proactiveness, it trains the individual also. The citizen in the smart city is smart now. This is the meaning of the smart citizen. This is the interconnected system, the smart grid. Every equipment is a communicable equipment, whether it is a wristwatch, whether it is a light, whether it is a fan, whether it is a OTG in the kitchen. Okay. So they every gadget nowadays has got a USB port. and you can program that particular gadget as and when and according to your wish. It's a great achievement and it is a great boon by the technology to the mankind. So it is just the interconnection of that. The if there is a disturbance in the grid, you can just observe here in the PowerPoint presentation. The generating plants are there and the generators are there. The transmission renewable sources are there. And on every home, there is a solar rooftop. Okay. Though the generation is very small, but if every house generates the solar power, I think huge amount of power can be generated from 10 to 5. Geographically, India is located at a very best location. You get approximately 10 hours or 7 to 8 hours a clear sunlight, isn't it? And it's a really great as far as the geographical placement of the India is concerned, that you can generate the power by using the solar part of it. Demand curve management, what I was telling you, this is the necessity of the energy consideration for the smart city. Now imagine when I delivered one lecture on demand and power supply management. See, it's a technology, it's a concept in Japan that I do not know how many of you have gone through the energy bills at your home. See, as far as the policy which is framed by Government of India as the solar policy, if it is a commercial installation who is supposed to or who is interested in having the solar PV on the rooftop, then evening 6 to night 10, this much time, uh, the adjustment is not possible. During this period, even if you have generated so much amount of power from 10 to 5, but that particular offset and set off is not possible in 6 to 10 p.m. Why it is so? Because in India, 6 p.m. to 10 p.m. is considered as a peak load period. Now, what is the peak load period? In this particular period, industry is also on, residential load is also on, agricultural load is also on, street lights are also on, railways are running on electric supply. So everybody is on, or every gadget is on. So the peak demand is very high in this particular part, and the utility is bound to get money out of it. Number one. And if in a day or in a week, if you consider that the demand goes on changing like this, which is shown here, we have to calculate the base load. What is the base load? Base load is the load which is always constant, it is always needed. I will just share one point as far as the base load is concerned. When our Honorable Prime Minister announced that in the last year pandemic Corona, that you have to switch off your lights for maybe 10 minutes or 10 minutes. It was a big chaos. And every engineer was very much surprised at what will happen to the power system. It's a very interesting story. I was a part and parcel of the committee which is formed in Nagpur Load Dispatch Center. That what is to be done? If the complete load in India, residential load, industrial load, everything was off because of the lockdown. Now, if the load is coming down like anything, then what is to be done? Then many people, they have suggested that the intention of the Prime Minister is not to switch off the air conditioners. You have to switch off the lighting source. Okay, so I instructed in my area that you switch on, let your fans be there, running condition, whether you require it or not, but it is necessary for the complete power system. See, if the load on the generators fall drastically below a particular benchmark, then there is a cascading effect. The generating station will trip one by one and there will be complete dark. Everybody was very much concerned about it. And I'm thankful to the all energy engineers basically that they made it. So basically base load is to be assessed. In India, base load is assessed with only one utility, and that is nothing but railways. The railway require electrical energy for running locomotives that decides our base load. And over and above the base load, whatever requirement you have, you can generate that particular part locally or throughout pan India also. So one primary goal of the smart grid is to help the level the electrical load via dynamic load management. This is the dynamic load management. Much of the difficulty and the cost managing of the grid stems from the variability of the demand. And for the most part, electrical energy from the grid cannot be effectively stored. That is very, I can say it is a disadvantage, but it is not possible also. It is the supply demand management. Irrespective of the fact that the generating power plant is the installed capacity is 200 megawatt, but it will not generate 200 megawatt. It will generate depending upon what is your load. You cannot store the energy. That is the main drawback of the thermal power generation, the hydropower generation, the gas power generation, and so on and so forth. The production or the generation should follow the demand pattern. Okay, so you have interim demand, peak demand, and base load. So if it is possible in the smart grid, in the microgrid of a smart city, if the base load, if the curve is flattened, it is not a flat curve basically. If the power demand remains constant, what can be done for that? What Japan has done. So there is a drastic difference between the peak load and the minimum load. What they announced that every industry will work in the night time. Okay, so the industry is running in the night time, and all the shifts, they have been arranged in a such a way that more or less the power demand curve is more or less flat, and that is good for the health of the complete power grid as a whole. It's the best example of Japan. Can we do it in India? No. Immediately there will be a procession of the workers. We cannot work at 12 in the night, isn't it? So the policy, governance, mentality must change now. So the demand curve management is very much concerned and is to be considered in the smart city. Because the generating plant is not only the plant, because in smart city, what we foresee that it should be a normal power which we take from the distribution company or the transmission company. Another power is nothing but the solar power generation. Third one is the wind power generation. Fourth one is the non-conventional some power conversion. The Prime Minister has just now announced on 15th of August that now we are marching ahead with the research in the hydrogen fuel. If that comes true, believe me, that will not be dependent on the diesel and the petrol from the Middle East. Hydrogen fuel, it is the vision which is given by Honorable Prime Minister. Every technocrat, every engineer, every research, science research, I think we should concentrate on how we can harness the hydrogen fuel. This is the fuel for future, right? Electric vehicles in the smart cities. Uh, I hand over the discussion to Mr. Chinmay Harkare. He is expert in electric vehicles and heat ventilation and air conditioning, how to minimize the energy consumption in that.
Hello everyone, I am Chinmay Harkare and I am part of the second generation. We are Technodil, we are here for 35 years and Deshakar sir is our mentor and he guides us. So we'll start with electric vehicles. So as the focus of the presentation from our side is the energy consideration for smart cities. We have to ensure that everyone gets power and the power is coming from sustainable sources. So instead of increasing generation, the focus should be on minimizing our energy demand first, and then what is left that can be catered using enhancement of the generation. Vehicles are responsible for 16% of CO2 emissions, which is a small number if you consider buildings do something like 40%, but still we have to minimize whatever there is. And electric vehicles in the next 5 years will become mainstream all over India. It has already started happening in the metros. If you go to Pune, Mumbai, Bangalore, these are much more popular. And the reason is that the technology in these areas is moving in strides, not happening up till 5 years ago. The main issue was batteries or the storage of power, which limited the ranges of the electric vehicles. And now you have vehicles which have 300, 400, even 600 kilometers of range. And so that issue has been sorted. India is also looking to become the hub for lithium ion batteries, which are the basis of all electric vehicles to make them feasible. And so it is a well-established fact now that in the next 5 years, electric vehicles will become mainstream. Petrol already has it 110. It is going to keep on going up. This is also known to everyone. Now, as far as smart cities are concerned, as sir also pointed out, that solar power generation is something which needs to be tapped as it is the cleanest source of energy. The biggest issue for solar, we'll cover that in the next slide, as how electric vehicles and solar power are complementary with each other. Now, obviously, there have to be incentives from smart cities for people to adopt electric vehicles, which is going to be beneficial for the environment and will help the smart cities achieve their targets of sustainability. Now, as I was mentioning, electric vehicles and solar PV, it has become a very lucky combination. The biggest issue with solar power for decades has been that you cannot store solar power, or the feasibility goes for a toss the moment you say that you'll have a battery system where you store power. Nowadays, solar is becoming popular ever since the grid tie inverter technology has matured, where you can directly export power to the grid. And so there is no need for the batteries. But that is also the drawback of solar power, that despite having power, you cannot store it for your own use. You can look at electric vehicles as moving batteries. Now, they inherently are going to need to have the lithium ion batteries. And those can be coupled with your solar PV generation plants in your homes for rooftop or any other case. And then they can store power for you, as can be seen in this particular image. Currently, what is happening is you have electric vehicles in your house, you plug them in and you charge them and you drive them around. What is going to happen in the future, or the research is happening in the area where you have V2G, which is vehicle, V2H, which is vehicle to home or the building, and V2G, which is vehicle to grid. What you can do is, when you're generating excess power, it will be used to charge the battery of the solar vehicle. And suppose there is an outage and you don't need the power backup batteries for your home, you can use power from your electric vehicle and there will be a reverse flow of power. Similarly, there can be a case where you are exporting power from your vehicle to the grid. So electric vehicles, they have come as a boon that free of cost you are getting a battery storage for your remaining ecosystem of solar power. This is what I just explained, that there are 3 or 4 ways how power can flow between your electric vehicle and your home, and how they are beneficial to each other. Now that is all about electric vehicles. Now I'll move on to green buildings and smart cities, because Deshakar sir has also been focusing on the point that out of all the aspects of a smart city, sustainability is going to be the most important part. That all the things should be sustainable. We should be using clean sources of energy, and our carbon footprint overall should go down. Whenever we hear green buildings, it is unfortunate that there is still very low awareness among the general population. People think that a building with lots of trees and lots of vegetative areas are green buildings. That is far very, very incorrect. See a green building from outside, you may not even know that it's a green building, but it can be one of the best green buildings in an area. It can be a net zero building and you'll not even know that it is a green building. So by definition, it should use its resources efficiently. The building materials should be eco-friendly, and it should have a very low impact on its environment. Those are the features that make a building green. Efficient use of all the resources, as I just said, be it energy, water, and it should focus on using renewable energies rather than conventional forms of energies, which release carbon dioxide into the atmosphere. Pollution and waste reduction measures. It should have good indoor environmental air quality. As I already said, that the building materials themselves, right from your paint to your plywood, there are green certified products in all of these ranges, which are non-toxic, non-lethal to the environment. And one other aspect is, you cannot just go ahead and have a very basic kind of a building and then say that it is a green building because it is consuming very little power. You cannot have, say, a space where you do nothing, you just install basic lights and fans, and you keep it closed on all sides, and then say that it is a green building because the power consumption is very low. All the green building certification authorities, be it the Indian Green Building Council, the US Green Building Council, or LEED, they say that in addition to being sustainable or eco-friendly, you have to ensure that the occupants have certain levels of comfort, be it the indoor air quality. There are several such aspects. There are 100 points, out of which you have to ensure that it meets those mandatory criteria in addition to being eco-friendly. And once again repeating that whatever it does, it needs to have a minimum impact on environment. Something beyond green buildings nowadays, which is becoming popular, are net zero buildings. We'll also come to that. Now, in the previous slide, I said that vehicles are responsible for about 18% of carbon emissions, whereas buildings are responsible for 38%. So this is almost 1/3 of your overall energy use in any city or globally. So addressing your building's energy use has to be right up there at the top when you're thinking of smart cities, because these are the bulk energy consumers in your overall ecosystem. As the developing nations develop, their consumption is going to increase with people's ability to afford high-end equipment, and air conditioning rises. You're going to need more and more electricity. In a typical building, air conditioning, it is well known, consumes the biggest chunk of the pie at about 35% for a general building. And so to minimize the energy consumption of a building, a good HVAC design is essential, because that is your biggest power consuming equipment. For a smart city to achieve its energy sustainability goals, it is thus going to be critical that all the buildings which are there in your city have also need to be eco-friendly or energy efficient. Coming to the Energy Efficiency Building Code, or the ECBC. So this was done by BE, the Bureau of Energy Efficiency, in 2007. The latest revision is from 2017. And the issue is that currently this code, so it establishes the minimum energy performance standards for the buildings in India. Currently, it only has standards for buildings which consume at least 100 kilowatts or more. And the big issue here is that this code is voluntary in nature as of now. The central government has laid it down. The state governments have the authority to modify it based on area to area. But it is not a compulsory code that every building must follow. For smart cities to become environmentally sustainable, they need to think of policies to ensure that the ECBC, at least in some form, is made mandatory for the buildings which come in the area under its jurisdiction. Because without that, the energy targets will not be met for the smart city as a whole. So the ECBC gives you a parameter called the Energy Performance Index, or the EPI. So this is basically the energy consumed per square foot in that particular building. And then that gives you the EPI ratio, or the EPI of the proposed building, or the building which is under construction or being planned, versus the EPI of a standard building. Like, say, for example, you are building a school, a hotel, a hospital. There are going to be standard base cases in the ECBC for all of these buildings, that a hospital of, say, 40,000 square feet, which is this kind of a hospital, its specialization, it should consume this much power or this much energy per year. So based on that, whatever is your proposed designs, they make you do the calculations or the simulations and prove that this is going to be my API ratio. And even post commissioning of the building, you have to submit the energy meter data for all of the systems to ensure that you are consuming energy less than the standard building of that particular category. ECBC currently has got 3 categories. Your building can either be an ECBC compliant building, it can be an ECBC plus building, or it can be a super ECBC building. So all of these categories will have, like, obviously the super ECBC building will have the most stringent criteria. Your EPI ratio has to be much lesser than the base case of how much energy you consume, and even the construction materials and all. Now, as I already said, that energy metering is compulsory for green buildings for all of the agencies which give you the certification. And you have to submit the data of how much energy you are actually consuming in the building versus the base case. Now, the benefit of energy metering, Deshakar sir has already said that in smart systems, data is going to be something which now can be analyzed to help improve your future designs as well as your current things. What happens is, you should continuously monitor the amount of electricity being used in lighting in your building, on air conditioning, on pumping, on all types of loads. And the moment you see that there is a sudden rise in any of these consumptions, you know that there is need for maintenance or something is not right. During the design, you consider certain criteria, you design all of these systems. At commissioning, things work as per what is being designed, but after 5 years, 7 years, the performance of all the various aspects of the design, it naturally goes down, the efficiencies go down, and you know that there is a time for a retrofit, or you need either maintenance or you need to replace certain equipment. So that is the other advantage you get when you do energy metering for a building, which is a mandatory requirement. Now, for energy efficient buildings, the ECBC will give you the LPD, or the lighting power density, which is the maximum allowed wattage for lighting, which is allowed for all internal lighting. So it lists the maximum LPD according to the type of building, which can be offices, hospitals, hotels, malls, etc. And this obviously is dependent on the lux area which is recommended in each of the areas. So to apply for a certification either through ECBC or for being a green building, you have to ensure that the occupant comfort, like I said, that indoor air quality has to be good. Similarly, the lighting level should be within the specified limits, that they must get that much lux level and in all the spaces. But then you have to achieve that lux level without exceeding the wattage of the overall lighting fixtures in your building. And this is not that difficult a criteria to meet in most of today's buildings, because LED fixtures have gotten so efficient in terms of the lumens per watt that the only thing you have to do is you have to use LED lighting in the building, and that takes care of this particular criteria, that you do not exceed the lighting power density. Now, this is the point which I would like to focus on the most in this particular presentation. The building envelope. This is the most neglected aspect of a building design all over the country. The awareness is very, very low, and the effect this can have in reducing your air conditioning bills is immense. We have also done some base case or standard case examples in the upcoming slides, and you'll get to know how much of an impact having a good building envelope can have on your building. As I already mentioned, that the focus, instead of being on increasing your generation, should be on minimizing how much electricity you require. Similarly, in air conditioning, rather than spending a lot of money on very, very expensive equipment or air conditioners which are 5-star or very, very efficient, you should first focus, or the architect's first focus needs to be on passive design strategies to ensure that by default, without an air conditioning, the space will remain cool throughout the year. Then whatever is the balance required to reach your target temperature, that is something which should be looked at using air conditioning. So there is a term called the mechanical, cooling installed in the building. The need for that should be minimum. A mechanical cooling can be air coolers, they can be air conditioners. We should first minimize the requirement, and then we should bridge the gap using the equipment. ECBC recommends energy efficient values for the building external glass, thermal conductance, and the solar heat gain coefficient. The thermal conductance is how much heat from the atmosphere gets into your building through the windows. The solar heat gain coefficient is because of the direct incident sunlight which falls on your glass. Out of that, how much heat will get in and how much of it will get reflected back. So the ECBC has got certain minimum values which you must meet for these particular windows in all of the buildings in your building, to ensure that more than that heat is not getting in. But again, there is also going to be that catch. You also want light to enter your building. So if you have a fully 100% reflective glass, you will have no solar heat gain, but then you will also not get any light. So they also give you a criteria of visual light transmittance. VLT is also an index for the glass. It also has to be within the acceptable limit. So they want light to come in, but the heat to remain out. Most of you must have seen the advertisements on TV from Seth Gobin, which is the pioneer in energy efficient glass. They have very good glass. They have silver coated glass. They have economy glass. They have very, very expensive glass. And unfortunately, all of these things need to be done during the building design phase itself, which gets neglected. And the calculations and simulations need to be done, that what kind of glass should be used in a particular building. See, you can just go out and say we'll use the most expensive glass, but you need to ensure that the payback is such that you are not wasting money on that rather than spending that money on more efficient air conditioning. Similarly, all air conditioned areas need to be completely sealed, caulked, gasketed, to ensure that there is no air leakage. And the exposed roof design must be such that its U value of the complete assembly meets the minimum values according to the code. This is quite basic. Anyone can understand that the roof is one of the biggest heat sources which enters your building, and a good roof treatment is essential. Yes. This is a photograph of an overdeck insulation being done. So they do that after the waterproofing stage. They put these insulation panels on the terrace, and then they do the final IPC or the tiles, whatever is to be done on the terrace. And this makes a huge impact on how much heat actually enters your room. You will be surprised to know that people are, unwilling to get flats on the top floor because they are afraid that it will, heat up a lot. But if the roof has been treated properly, you will find that your top floor is cooler than maybe other floors, because proper treatment can completely eliminate the heat which is coming in through the terrace. Similarly, in addition to your roof, your walls can also be insulated, and they should be insulated. ECBC gives you a criteria, and to meet that, insulation is the only way you can have that particular U value for your walls. You must have heard about cavity walls, where there are two walls with an air gap in between to keep the heat out. Then there are insulated walls as shown in this picture. Shading can make a huge impact. You can have a south facing or a west facing window, but if you do proper shading design, the heat coming in from that window can be the same as that comes in through your north window or a shaded window. Shading design itself is in itself a huge subject, because you want to ensure that you get light during the winters, but you do not get the heat from the sun during the summers. So complex simulations and calculations are designed just to know that what should be the size of your A, and as a function of your height of the window, which is B, which is called as the projection factor. These things need to be done for all the buildings which are coming up, but these are the most neglected things, unfortunately. I put this table intentionally to highlight two things. See, if you have a window, and say for a base case there are no curtains or no shading devices installed, if one is the factor of how much heat comes in through that, or solar heat comes through that window, when you have blinds from inside, that number is 0.56. But if the same blinds are installed outside the window, that goes down to 0.13. So what you can know from this is there is no additional cost. There is no rocket science involved in this, that just by having blinds outside the window instead of inside the window, the reduction is almost 4 times. It is what, 13. You are getting down to less than 25% of what would have come in if you have blinds outside. So these are passive design strategies. These do not require added cost in your building. People think that green buildings are costlier than your conventional buildings, which is a huge misconception. You just need to spend a bit of time in the planning and design to ensure that you'll have a green building, which will cost you the same as a regular building. To give you an idea, this is a simple 15 by 25 feet room which we designed yesterday, and we are calculating the size of air conditioning which will be required for this typical building with three windows on one wall, three windows on the total 6 windows. It is 10 feet high and a 15 by 24, 375 square feet space. This can be anything. This can be a school classroom. This can be a hotel room. This can be an office space. And if it is oriented in such a way that your windows are on east or west walls, you can see that the required size of AC tonnage is 4 TR. This is as per actual calculations. But simply by rotating the orientation of the room, see now the windows are on the north and south walls, you have reduced 0.4 tons of your air conditioning of your air conditioner. The building is the same, the cost is the same, and the structure is exactly identical, except for the fact that your windows are on your north and south walls instead of your east and west walls. And 0.4 ton has been reduced forever. The building is going to stay there for 50 or 60 years. Similarly, the orientation of your building, you want to have your south and north walls to be, so you want your building oriented from east to west, which means that the shorter walls are on east and west from where the heat comes in, and your longer walls should be on north and south. Now, as I already mentioned, the ECBC has got certain criteria for each of these building types as to what the building envelope should be, which is the quality of the glass and the structure of the roof and your walls, your external walls, to ensure that the heat remains out. And how much of a difference can that insulation in this way on your terrace or insulation in this way in your walls can do is demonstrated by us in this particular slide. This is the exact same room. You can see no difference. Both are oriented east to west. Both have the same sizes of windows, same size of the room walls. This requires 3.6 TR. The air conditioner is 3.6 TR in this particular room, and here you need a 1 TR AC. You have reduced the size of your AC to by I think more than almost 1/4, by 75%, just by ensuring that you use good quality of glass and you insulate your walls and you insulate your roof. You take a moment to think of what has happened. It is going to cost you money to insulate your walls and insulate your terrace. There is no doubt about that. But the cost of that insulation will be the same as the amount you will save on your air conditioning. See, a 1 TR AC is going to be along the same proportion cheaper than a 4 TR AC. So the money which you save on your 3 TR AC can be used in insulating these things, and forever you have reduced 3 tons of air conditioning from this room, which would have run for 8 hours a day on all working days throughout the building lifespan of 50 or 60 years. So that is where we always tell all our clients that instead of focusing on very costly or high value brands of air conditioning which are super efficient or technologies, you should first focus on your passive design strategies, which is something the architect and your air conditioning guy need to work closely on to ensure, because the architect will know that these are the benefits of doing this, but he will not have the maths associated with calculating for each case. Like your air conditioning person working with the architect can tell you that on this side you use this quality of glass, on this side there is more heat gain, you use a more expensive glass. This wall, it is okay if you don't insulate, but this wall you put this many inches of insulation, and then he can give you the exact reduction in tonnage in each of those cases, like has been done in these two cases, and then they can do a calculation of how much money is saved on the air conditioning and how much money is required for the measures being taken, which can give you a return, ROI, or the payback period of what is being done. Now, this is a simple room which we did just for understanding, but this is an actual project. It is an IT building in Mihan. Instead of focusing on all the complicated numbers here, you just focus on this. This is the base case where you need 74 tons of air conditioning for that particular building, which translates to 132 square feet per ton. So 1 ton of AC can cool 132 square foot of space. And by the measures which we recommended, they only need 46 tons. That is what a reduction of 30. About 34 tons of air conditioning has been reduced from that building just by implementing, and we have also mentioned that what needs to be done. This should be the construction of the wall. Instead of using red brick walls, you use AC bricks. You use 2 inches of insulation. Instead of normal plaster, you use 1/2 inch gypsum plaster. What is going to be the value of the glass on each of the sides? And so these are the things which ideally should happen in all the buildings of a smart city to ensure that they meet their targets of reduction in energy consumption. So that's about it from my side.
It is over from our side. I think now the forum is open for the question and answer or some clarification you want from our side.
Yes, thank you, sir. That was an informative session, and I request all the participants to join the discussion, and they can raise their hands or they can post the questions in a WhatsApp group.
Stop presentation right now.
Yes, sir, please go ahead.
Hello, are you hearing my voice?
Yes, yes,
Yeah.
yes.
Hello.
Yeah.
Okay. Uh, Actually, I am listening the electrical sustainability as well as solar passive architectural features to reduce to generate the energy efficient buildings.
Yes.
So my query is what kind if we want to change because I am the faculty from architecture. So if we are going to rely on the passive shading devices in terms of built-up form of the building, as well as with what you can say brick coefficient of thermal absorption and all those
Yes, sir.
properties of the material has been applied. So
Yes, sir.
in that situation also the air conditioning cost or thermal cooling or comfortable living conditions can be maintained in the indoor spaces.
Sir, could you repeat the last part that if all the things have been used, then?
Then is it possible to maintain the thermal comfortable condition in the indoor spaces? As you have already told you, cavity wall concept and insulation, then roofing system, as well as the glass which has to be reflective,
Yes.
etc. By
Yes, sir.
understanding the coefficient of absorptions. Okay.
Yes. Sir, if I understand you correctly, are you asking that by using these passive measures can we completely eliminate air conditioners, or is that the question?
Completely or minimize the air conditioner
It
system
Yeah,
or
of
definitely
course.
can,
air
sir.
cooler.
It definitely can, sir, and that was the point of those 2-3 slides. And we intentionally did those, case calculations yesterday to demonstrate that for the
Yeah.
same room, you need 4 tons under normal scenarios, and by applying those measures, you only need 1 ton. Now, please keep in mind that that kind of a drastic change will not happen in all general buildings. That is why I also showed you a actual live case scenario where it reduced to about 60 to 65%. It does reduce, but it does not get eliminated completely. But yes, there is 100% reduction. Sir, and now what needs to happen in our overall construction industry all over the country is there has to be an integrated design approach. And this is something the client needs to, he should be on board with this idea that his building needs to get designed first before he actually builds the building. And he needs to get the electrical consultant, the air conditioning consultant, the architect, the plumbing consultant. These people need to sit together on the design, and that is how these things will happen. Because sir, as you said, as the architect, you know that there will be some reduction, but you cannot go back to the
Yeah.
client and say कि हाँ अपन सेंट गोबेन का ही इतना महंगा ग्लास यूज करेंगे, because you need to have the numbers. The numbers which Saint Gobain will give you are going to be very generic. They will not be specific to your project. So in that way that can be done, and that hopefully should be the trend for future construction in the country.
Okay. Thank you. Thank you. Because through calculations you are given, that is much more important.
Yes,
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 sir,
yes.
yes.
And we are practicing
Yeah.
this in Nagpur. This is the
Yeah.
last slide which I have shown, is the live example. The one in industrial
Yeah. Yeah.
area, one 400 terminal IT complex, we are just handing it over on 14th. And we have given the guarantee to them that your payback will be within 1.5 years or 2 years.
Yeah, very good, sir. Very good. These practices are important because in Nagpur also, very less structures has been built in such a fashion.
Yes, yes, yes.
Yeah, yeah. Thank you.
Thank you, sir. Thank you.
Thank you, sir. So there is another question by a participant. What should be the proportion of door and windows with floor area to achieve green building norms?
See, it is given in the guidelines of your IGBC. It is given in your ECBC. So based on what I have on in my head, I think it is something around 30%. But then that is a number which can be looked up. It is easily available online. I think it is around 30%. The window to wall ratio.
Thank you, sir. There is another question. renovating of the existing old buildings such as the ancestral houses like authentic Chettinadu big houses in Tamil Nadu will be a costly affair.
Can you repeat the question, madam?
Renovating renovating of the existing old buildings will be expensive.
See,
Like he also gave the example that
in terms of general architectural renovation is being done, or are deep retrofits being done? Does it have air, or does it propose to have air conditioning? Because I'll tell you one thing, based on what when we come to renovations or retrofits, we have been very fortunate enough to work with Infosys in almost all of their campuses all over the country, and their Pune campus, which is huge, it luckily holds the record for being the only platinum rated green campus all over the world in the EB or the existing building category. So what that means is that campus was more than 20 years old, and yet it has achieved the platinum rating in the LEED certification, wherein through retrofits they have achieved all those targets. So it is very easy to do things like this in a new construction in the planning stage itself, but they have achieved that even in the existing building, which was 20 years old. And we were very fortunate enough that we were also part of that project, where we handled the electrical part of what was being done there.
Thank you, sir. I guess that is the clear answer for the participant. If there is any other question, you can raise your hands as well. So I don't see any other question here, sir. So we reach the end of the session.
For madam, for any query further, we are absolutely open, right?
Yes, sir.
Yeah, we are absolutely open for any type of question as far as the building services are concerned.
Yes, sir.
So you can share our contacts with the participants, and they can, connect with us, email or phone anytime. No issue.
Yes, sir. Yes. So thank you, sir. So that was a very informative session, and you rightly focused on the topic and explained it with a great expertise. So I want to extend my generous thanks to both of you, and I want to thank for your valuable time, and also I want to thank for sharing the graceful opinions with us. Thank you so much, sir.
Okay, we are also thankful for providing us an opportunity to have the faculty or the presenter in this FDP. I'm thankful to Agrawal sir, right?
Sir, thank you very much for nice presentation, and it was very much informative. Particularly the practical aspects you covered. I think practical aspects were excellent.
Okay, sir. Thank you.
Thank you, sir.
Okay, thank you. Can we log out now, sir?
Yeah, sir. Thank you, sir. Thank you.
Okay.
Thank you, sir.
Right. Thank you.
So I thank all the participants for their active participation, and we will be gathering here at 9 a.m. The first session will be from Dr. Amba Sethi. Thank you so much all.